Welcome to the OhioFirst.net training module. What is LTE? Over the course of the next few minutes, we'll teach you about the cellular technology called LTE, how public safety will use it for the nationwide public safety broadband network, and how some of its features will be very beneficial for public safety. So, what is LTE? LTE stands for long-term evolution, and it is the technology behind today's 4G cellular networks. The cell phone you have today almost certainly uses LTE to connect to the cellular network. LTE provides high-speed mobile broadband data, digital cellular telephone service, supports multimedia video and public safety functions like secure database access, mobile CAD and RMS, and non-mission critical push-to-talk. You are using LTE today. All major smartphones and cellular devices manufactured since 2011 support LTE and use LTE for data access. And all major U.S. commercial carriers support LTE, including AT&T, Verizon, Sprint, and T-Mobile. They all use the same technology to provide high-speed mobile data to their customers. And it's not just the United States. LTE is a global, open, interoperable standard for wireless high-speed cellular data. It is used by virtually all carriers in the entire world for the current generation of cellular communications. LTE is also the technology endorsed by public safety for the nationwide public safety broadband network, which will be built by FirstNet. This is true in the United States and abroad. LTE is the technology that all public safety agencies across the globe intend to use in their future mission-critical public safety broadband networks. And, even better, by adopting LTE as its next wireless technology standard, public safety will always keep pace with current technology. LTE is the current version and standards developed by the organization called the Third Generation Partnership Project, or 3GPP. Approximately every 2 years, 3GPP releases a new version of their standards. LTE just represents the current version of these standards. This means that by adopting LTE for FirstNet and the nationwide public safety broadband network, public safety is already prepared for 4G and 5G in the future. So while 5G technology might have a different name and won't be called LTE, it will essentially just be a new version of the same technology. So what does an LTE network look like in the real world? An LTE network has 4 major components or subsystems. First is the core network, which is the brains of the network. It consists of servers and gateways that control access, quality of service, billing, and network policies, and the core provides access to the internet and multimedia services like telephone calls. Second is the radio access network. The easy way to think of this is that the radio access network are the sites that you see, the cell towers. These towers have transceiver equipment called eNode Bs and antennas and provide wireless coverage for your device. Third is the backhaul network, which is made up of fiber and microwave connections. The backhaul network connects the radio access network to the core network. The backhaul network represents the roadways where the data gets from you and your device back to the core network so you can access the network, make telephone calls, and access other network services. Last but not least is the user equipment, which consists of cell phones, mobile routers, and other devices used by individuals. Your cell phone would be considered user equipment. The user equipment connects directly to the radio access network. This is the subsystem you are probably most familiar with because your cell phone is a piece of user equipment. LTE has many features and capabilities, but there are 4 aspects to the LTE-based nationwide public safety broadband network that will really be very beneficial to public safety. These 4 features are exclusive spectrum, high-speed data, priority and preemption, and the self-organizing network, or SON. FirstNet, who is responsible for deploying the nationwide public safety broadband network, has access to exclusive frequencies that are not shared with the general public or other users outside of public safety. This is a really big deal and one of the main reasons that the service will be useful for public safety. The frequencies allocated to FirstNet and the nationwide public safety broadband network are in the 700 MHz range. These are the same frequencies that were previously used for broadcast television before the digital TV transition a few years ago. These beachfront frequencies are very valuable and are extremely similar to the frequencies powering the lightning-fast commercial cellular networks today, including Verizon and AT&T. As you can see, however, the frequencies for FirstNet and the nationwide public safety broadband network are completely separate from the frequencies for major carrier networks. This means that during a major disaster, when commercial networks get overloaded and fail, first responders will have their own frequencies for mission-critical communications. For example, have you ever been to a big event where there are a lot of people, and even though you have good coverage and a strong signal, you can't get through to the network? That's because there are so many people using it. With the nationwide public safety broadband network, this won't happen to first responders because they'll be on their own frequencies. The second primary benefit of LTE for public safety is its high speed. This is true both for a commercial carrier who uses LTE as well as for FirstNet and the nationwide public safety broadband network. LTE networks are typically designed with 3 sectors at each site, and each sector supports the same amount of data. This 40 megabits of throughput is shared by all users in each sector. Let's look at a few examples. In this example, there are 2 users in the northeast and south sectors and 1 user in the northwest sector. You can see that in the northeast and south sectors, each user gets about half of the bandwidth, or 20 megabits, while the user who has the northwest sector all by themselves has 40 megabits per second. In the second example, you can see that there are more users in the south and northwest sectors. In the south sector, because there are 3 users, each gets about 13 megabits per second, or about 1/3 of 40 megabits each. In this last example, we see that we have 4 users in the northeast sector. Because there are so many of them, each user only gets about 10 megabits per second, or 1/4 of the total 40 megabits for that sector. You can see still each user in the south sector gets 13 megabits and each user in the northwest sector gets 20 megabits per second. This is a really important concept in LTE. Each sector supports about 40 megabits per second of data. As you get more and more users in that sector is going to be much slower. This is why when you're at a large event, you won't get very fast internet service from your cell phone. Because even though you have a good signal, there's so many people sharing the same antenna that there just isn't enough data to go around. The third major advantage of LTE for public safety is the ability to configure priority and preemption of traffic. This allows the network operator to make sure that the most important traffic always gets through no matter how busy the network is. This example shows the network assigning the same level of priority to 4 users at the same site. Because they all have the same level of priority, priority 7, they're each going to get 10 megabits per second for their traffic. In the second example, we see that the user on the left-hand side has a higher priority than everyone else. So everyone else gets a lower speed at 8 megabits per second, while our one user at priority 2 gets twice as much throughput at 16 megabits per second. This is an important concept in public safety because going into the future, public safety agencies will be able to determine who and what deserves higher priority and should get more data access than other users or applications. In this last example, we're showing preemption. The user on the left not only has higher priority than everyone else, but is making an emergency call. You can see here that the second user is assigned priority 9. The first user is a priority 1. In this case, the network would decide that the priority 9 user can wait and would allow the emergency call to completely preempt that user's traffic. Last, and certainly not least, is the self-organizing network, or SON. And while there are many features that go into the self-organizing network, the one that we're going to talk about today for public safety is the ability of the network to repair itself during outages. In this example, we see that the site on the north has lost an antenna, and the sector on the southwest for the north site is no longer on the air. In a traditional network, such as a trunked radio system, this area would simply have an outage. You would have no service there. But LTE networks can be set up to accommodate for those outages dynamically and on the fly. In this case, the site on the south has increased the power for its north sector to cover the outage area temporarily. This allows the users in that sector to still have service. Now, that sector is larger, so there are going to be more users sharing that same sector, and those users will all have lower throughput, but it's better than having a complete dead spot. Once the southwest sector on the north site has been repaired and is back in service, the network can automatically go back to its original state and power down the sector at the south site that had increased its power to cover the outage area. This all happens automatically in LTE with the self-organizing network feature. This means that the nationwide public safety broadband network can have a much higher degree of resiliency and survivability than we're accustomed to with our legacy networks. To wrap up, you should now have a better understanding of what LTE is and the benefits that it has for public safety. LTE is a global standard technology for cellular communications. It's endorsed by public safety and virtually every carrier worldwide for cellular communications. LTE has many features that are attractive to public safety, including exclusive spectrum, high speed, priority and preemption, and the self-organizing network. And we know that by adopting LTE as the technology for FirstNet and the nationwide public safety broadband network, public safety is already future-proofed for 4G, 5G, and beyond.